Good day, class, and thank you for attending our discussion for today. So, for our meeting, we will discuss your activity 2 in your immunosero laboratory, which will deal with agglutination. So, in most of your tests in immunosero laboratory and even immunohematology, the tests are based on this test or in this principle agglutination, which you will learn about in this discussion. Now, agglutination class refers to the cross-linking of a particular antigen to form larger complexes that are also visible. So, in your lecture class, it was defined what is an antigen. Now, if we are going to go to the definition of antigen, let's talk about the two types of definition it has. The first definition of an antigen class is that it is any foreign or non-self or may or pa ako klasa or self material found in our body. So let me repeat. The first definition of an antigen class is that your antigen is any foreign slash, let's just use slash class, foreign slash non-self or self material found in our body. When we say foreign or non-self class, these are substances not present in our body normally, such as foreign bacteria, cells, or later latex particles. But there are some cases, class, wherein our body would treat our own cells as antigens or as foreign substances. And when this happens, class, a disease or a certain type of disease or series of diseases would occur known as your autoimmune disorders. Imagine, class, in an autoimmune disorders, imagine your own WBCs, your own antibodies are attacking your own cells. An example of this in your hematology, the so-called AIHA, also known as your autoimmune hemolytic anemia. In autoimmune hemolytic anemia class, antibodies would destroy your own red blood cell. So that's one definition of antigen class. These are any foreign slash non-self or self material found in our body that let me add so that we're clear that can cause an immune reaction. So let me repeat for the third time. Your antigen, one definition is that it is any foreign, non-self or self material found in our body that can cause an immune reaction. So that's the first definition. Now, the second definition class of an antigen is that they are normally receptors found in bacteria, viruses, and other foreign substances. So do take note of that, class. Antigens are sometimes defined as receptors found in bacteria, viruses, and other substances. So sabi dito, class, agglutination is the cross-linking of a particulate antigen to form larger complexes that are also visible. From the word particulate antigen, there's the noun particle. And an example of a particle antigen, as mentioned earlier, bacteria, cells, and even latex particles. So do remember the two important definitions of antigen. Now let's continue. Now, agglutination is the process that would occur if an antigen is mixed with its corresponding antibody called isoagglutinin. Now, antibodies class, in most immunological reaction, it would usually involve two things, antibodies and antigens. Now, antibodies class are usually or normally specific. When you say specific, they would usually stick to one target antigen. So if naturo na, if it was discussed in your lecture, the appearance of your antibodies are normally Y-shaped. Ganyan siya. Ganyan ang itsura niya. They are Y-shaped and it has two important parts. The FAB part, FAB, and the FC part. Now what happens here is that the FAB part will attach to its corresponding antigen. So ganito, let me give you an example. This is, let's say, a bacterial antigen, and among its surface class, you would find certain receptors known as your epitopes. The epitopes class are found in the surface of your antigens. They are the receptors class wherein your antibody will attach. So ganito siya. I'm sorry if I have a terrible drawing. The antibody would attach to the receptor or the epitope of the antigen, forming your agglutination. So another name of antibodies is isoagglutinin. Now, agglutinin, also known as your soluble antibody, would form a lattice with an insoluble particle or cellular or surface antigen. The formation of clumps of cells or inert particles by specific antibodies to surface antigenic components. This is known as direct agglutination. So kapag direct agglutination class, this is wherein antibodies would bind to surface antigen components. Yung pinakita ko nga kanina. Yung surface antigen components, those are the epitopes. So the antibodies will attach there and that would lead to agglutination, specifically direct agglutination. So later in the coming slides, mas maintindihan niyo siya. Now, agglutination could also be defined in another term class. So, to antigenic components adsorb or chemically coupled to red cells or inert particles. So, sa direct agglutination kasi class, you have to take note that you are using particle or particulate antigen, such as nga yung bacteria, fungi, viruses. But there's another type of agglutination known as your passive agglutination. In passive agglutination class, the antigens are adsorbed or chemically coupled to red blood cells or inert particles. So there is an absorption or an attachment which later you will understand. Later you will understand the difference between a passive and a direct agglutination. But I just want you to know that there are two major types of agglutination, yung direct and yung passive. Now let's go first understanding the two stages of agglutination. So the first stage class is known as your sensitization. Sensitization class involves the initial binding of antibodies to the red cell antigen through non-covalent bond. So this is an example class of sensitization. Here you have your red blood cell. Your red blood cell here class serves as an antigen. Now in the surface of RBCs or your antigens, you will find these receptors. These are known as your epitopes, the ones that I mentioned earlier. Now this epitopes class, this is where your antibody, so these are your antibodies, the Y shape. They will attach to the epitope of the RBC antigen through specific bonds known as non-covalent bonds. So if asked in your quiz, what type of bonding does occur in sensitization between antibody and antigen? it would be sensitization. So let me repeat the question. What type of bonding would occur in sensitization between an antibody and an antigen? The answer would be non-covalent bond. So that's the sensitization class, wherein one antibody would attach to one antigen via the epitope found on the antigen. And remember the part of the antibody, yung part ng antibody that attaches to the epitope is the Fab site or the Fab part. Do remember that. Now, the binding of a single antibody to a single red cell antigen is not visible to the naked eye. So, during this initial stage class, there is no visible agglutination. Let me repeat. In sensitization, there is no visible agglutination. The reason for that class is because a single antibody is not enough for agglutination to be visible to the naked eye. So pakitandaan, please remember that. Again, a single antibody to antigen reaction is not enough to produce a visible agglutination. Several factors can affect the equilibrium constant on the antibody that dictates how strongly it binds to the corresponding antigen. So to simplify this statement class, the strength of antibody antigen reaction are affected by different factors, which we will discuss in the next slide. So the strength of antibody antigen reaction would be affected by different factors. These factors, class, please take note, can be manipulated to remove an antibody from an antigen. So imagine, class, if there's already an attachment, if there's already an attachment, by changing the factors, class, you can cause this reaction to detach or to remove. So do take note of that. So let's continue. Now, what are the factors that I mentioned that would affect sensitization? The first one, class, is pH. pH, class, is the recommended. There is an ideal pH for most antibody or antigen-antibody reaction. And the ideal pH, please remember, is 6.5 to 7.5. So that is the ideal pH for most antibody-antigen reaction. But there are some antibodies, class, that would react at an acidic pH. In your immunohema lecture, you will learn what different blood group antibodies would react at a stronger pH. So take note of that. Then temperature, class. So in temperature, I want you to remember two types of temperature when it comes to immunosero and immunohema. We have the so-called room temp and the so-called 37 degrees centigrade. Now, when we say 37 degrees centigrade, we're talking about here the body temp. And different types of antibodies. So, to give you an idea, class, there are 5 types of antibodies. IgG. Take note of the nomenclature, class. It's always capital I followed by small g. The capital I, small g here stands for immunoglobulin. That's the shortcut for immunoglobulin. Kaya siya tinawag na immunoglobulin if you remember in your clinical chemistry. Diba sa CC1 nyo, you have different types of protein. Pag ang protein nyo, if your protein class undergoes electrophoresis, if it undergoes electrophoresis, it would be separated into different fractions. And one fractions, class, is known as your gamma immunoglobulins, or also known as your antibodies. So immunoglobulin class is also another term for antibodies. So same lang sila. They are also known as antibodies. Now, there are five types of immunoglobulin or antibodies. Pakitandaan yung acronym na GAMED. GAMED. Immunoglobulin gamma. These are the definitions yan, class. IgG, immunoglobulin alpha, immunoglobulin mu, immunoglobulin epsilon, immunoglobulin delta. So I want you to remember, ang gusto kong tandaan, what I want you to remember in this slide is the nomenclature of writing antibodies or immunoglobulins. Start with the immunoglobulin nomenclature, capital I, small g, followed by the letter of the type of antibody. If it's immunoglobulin gamma, it's IgG. If it's immunoglobulin alpha, it's IgA. If it's immunoglobulin mu, it's IgM. If it's immunoglobulin E, it's epsilon. And if it's immunoglobulin D, it's immunoglobulin delta. So I hope that was clear. Now, back tayo sa temperature. Now, in room temp class, IgM antibody is the most active, or that is its optimum temperature. While the 37 degrees or the body temp, this is the most active, or the optimum temp of antibodies in our body. That is why class IgG is the most important antibody in our our body, because it can cause reactions inside our body. Kasi nga, it can survive, or its optimum temp is 37 degrees centigrade. So, yung mga antibodies that can cause autoimmune hemolytic anemia or AIHA are usually IgG in nature. So, take note of that. So, temperature also plays an important role. So, if you have an IgG antibody and you place this in a room temp, di ba, balik tayo sa previous slide. This one, they could be manipulated to remove an antibody antigen. Let's for you to understand. Let's say this antibody class is an IgG. Now, you decided to place the sample wherein the sensitization occurred at room temp. Since this is IgG class and you decided to place this in room temperature, and there's a change in temp, it's no longer the optimum temp of IgG, which is 37. Instead, it's already in the room temp. This will now cause class an illusion. And when you say illusion, this is where an antibody is removed from an antigen. So hindi na sila, it's no longer, the antibody class is no longer attached, but it would now be separated. So that's one factor on how the temperature can change or could cause illusion. Let's continue. Now let's talk about ionic strength class. So ionic strength class is removing the zeta potential, which can increase the rate of association between RBC antigen and antibody. Sige nga, let's have a review regarding your hematology 1 or your hemo 1. My question is this, class: what causes zeta potential in your RBC? So I'll give you time to answer. So the answer for this class is yung sialic acid ng RBC. So the sialic acid would allow for the zeta potential to occur. So to take note of that. Now, use of LISS is one way to reduce zeta potential. Ano ba tong LISS na to, class? LISS, class, is a form of NSS. It's a low ionic strength solution. So this LISS class would help reduce zeta potential. So take note of that. Low ionic strength solution. Then we also have the antibody antigen ratio. Equal amounts of antibody and antigen produces a zone of equivalence. So itong zone of equivalence na to, class, when you perform a reaction, you need to make sure that there is equal amounts of antibody and antigen. So if you're going to perform, let's say, a test that uses antibody and antigen, remember the most common sample where antibodies could be found is serum, and the most common example of an antigen used in the laboratory are red blood cell. So if you want to produce a zone of equivalence, you need to use equal amounts. So if you're going to use 1 drop serum, make sure that you would also use 1 drop RBC to produce a zone of equivalence. Prozone and postzone can cause false negative result. Now, when we talk about prozone, pag prozone, class, I want you to remember that this is excess antibodies. And excess antibodies would happen if, let's say, you added 2 drops of serum and 1 drop RBC. So that causes a prozone, which in turn can lead to a negative, a false negative result. While your postzone naman, if it's postzone, class, this is excess antigen. So this is the reverse. So if it's excess antigen, you would now use 2 drops RBC and 1 drop serum. So that's how you would differentiate prozone and postzone. Prozone, excess antibody; postzone, excess antigen. And both of them, class, could also cause false negative result. Take note of that. Now let's go to the second stage of agglutination, the lattice formation. So we're done with sensitization, class. So again, kapag sensitization, one antibody attaches to one antigen. So after sensitization, class, we go to the last stage, or your lattice formation. Now when we talk about lattice, once a red cell or inert particle is coated with antibodies, the binding of the antibodies to multiple red cells or inert particles would occur, and this would cause visible clumping. So from one antigen, one antibody, class, what happens this time is that multiple antibodies, class, multiple antibodies would attach to multiple antigens. Diba, remember that your antibodies have two Fab sites. Y2, remember it's in a Y shape. This is one Fab site. This is another one Fab site. So a total of two. So a single antibody, class, could attach to two antigens. So one, two, producing this lattice formation. And when lattice formation occurs, class, it is now the one. This is the stage where visible clumping could occur. So now you could see the clumping of RBCs. It's going to be visible in this stage. Now the formation of a lattice would require the ability to overcome the natural repulsion between two neighboring cells. Di ba yung, when we talk about the natural repulsion of two cells, class, we're talking about zeta potential. Again, sa zeta potential, there is wherein sialic acid residues are negatively charged would produce a negative cloud of electrons. Di ba nga, if you have the two same charge you would repel one another. In this case, class, yung sialic acid through the known as which causes zeta potential, magpuproduce siya ng it produces a negative cloud of electrons. Negative cloud of electrons. Now, this negative cloud of electrons would attract positive ions. And because of this, they would now repel one another. They would now repel one another. And to remove this repelling or repelling action class, as mentioned in the previous slide, you could use LISS. Now, yung antibodies niya, specifically IgGs, are too small to bridge repulsive forces. When you say bridge repulsive forces, this IgG class is in the form of a monomer. When you say monomer, mono from the prefix mono meaning one, it's just a single antibody. But IgM's class are large. Why large class? IgM's are in the form of a pentamer. From the prefix penta meaning five, made up of five antibodies yan, held together. One, two, three, four, five. And due to this large size class, they are capable or are large enough to bridge repulsive forces. So, pag ang antibody na gamit mo, if you're using an IgM type of antibody, there is a stronger lattice formation. So, do take note of that. Between IgG or IgM and between IgG and IgM produces a stronger lattice formation due to being a pentamer, due to having a large size. Now, this electronic potential or zeta potential is due to the negatively charged sialic acid on the RBC membrane. In a saline solution, the zeta potential also depends on the ionic cloud that surrounds the RBC. Now, let's talk about the factors that would affect lattice formation. We have the first one, agitation and centrifugation. So the force produced through agitation or centrifugation can bring antibodies and antigens together closer in physical space. So I don't need to explain this class, but you get the idea that when you centrifuge, you form a pellet at the bottom. Now, this pellet is produced class by the compactness of the different substances found in your in your sample. So the more antibodies and antigens present, the more compact it would be, and that would lead to lattice formation. That's why in your laboratory, most of the time, class, you're going to perform centrifugation. So take note of that. And then another one is to consider antibody isotopes. So yeah, this one. So as I mentioned earlier, IgMs are pentamer, so they have a stronger ability to form lattice, while IgG are monomers, lesser ability to form lattice. Since most of the antibodies we are interested are IgG in nature, a specific reagent containing IgG antibodies with specificity against the Fc or constant region of other IgG molecules was developed. So since ang target natin class yung IgG, 'di ba, as I mentioned earlier, IgG are the ones known to cause reactions inside our body. Ang mga scientists, they invented a specific reagent that would target the Fc region of other IgG molecules. So para magets nyo to, 'di ba, as I mentioned, this is your antibody. It's in the Y shape. This is the Fab. It has two Fab sites. And this one, itong parang trunk na to, this is known as the FC region. So what happens is that they created a reagent that would attack this FC region. So ang mangyayari dyan, this IgG antibody that they created would target this part. So ang mangyayari is like this. The Fab site, itong Fab site, the Fab site of the the antibody that they created would attach to the FC region dito. So mag-a-attach siya dyan. So later I will show you a better picture. Pangit kasi yung drawing. But you get the idea, class. Ah. They created an antibody that would target the FC region of IgG. And this test became known as your Coombs test or AHG. And AHG has two types, direct or indirect, which later I will explain. Then let's talk about the polymers class. So polymers or potentiators can enhance agglutination through the reduction of zeta potential. So both albumin and polyethyl glycol are thought to act by displacing water molecules in between RBC, which in turn decrease the zeta potential, allowing the red blood cell to come into closure. So itong mga polymers na to class, they enhance agglutination by reducing zeta potential. Example is albumin and PEG or polyethylene glycol. Then you could also use proteolytic enzymes. So enzymes can enhance agglutination by removing the negatively charged sialic acid, which reduces zeta potential. So you could use enzymes, specifically proteolytic, to remove the sialic acid, reducing zeta potential. Enzymes can also remove red cell glycoproteins, reducing the steric hindrance on antibodies interacting with the antigen. Examples of proteolytic enzyme are fisin, papain, bromelain, and trypsin. Do take note of that. So there are different gradings for agglutination glass. So when you perform your experiment wherein you would add your serum and you would add your RBC or your red blood cell or your antigen, it would produce different reactions. So if you after centrifugation class, after centrifugation, it produces a red cell. Now you would now shake you would shake the tube. After shaking class, if the red cell button is still one solid clump, it is reported as 4 plus. After shaking, if it produces several large clumps, it's now reported as 3 plus. If after shaking produces numerous smaller clumps, it's reported as 2 plus. If after shaking it barely produces discernible clumps, it is reported as 1 plus. And if there is a smooth suspension, it would be negative. So do take note of that. So again, when you add your serum and your RBC, you would centrifuge it. It would now produce a button, a red cell button at the bottom. You would now shake a tube. If it produces one solid clump, 4 plus. Several large clumps reported as 3 plus. Numerous smaller clumps, 2 plus. Barely discernible clumps, 1 plus. And if it's a smooth suspension, as in class no, there is no clumping, it's reported as negative. So here is a actual live appearance of the grading. So one big clump, larger clumps, a homogeneous negative reaction. So do take note of that. Then this is via the slide method class. So you will be doing this in your immunohematology laboratory, in your blood typing. But we will also be doing this class in your immunosero, in other tests. So take note of that. Now let's go to the types of agglutination. The first one is the direct agglutination. So when we talk about agglutination, these are the antigens that are found naturally on a particle. Example are RBC antigens, bacterial antigens, fungal antigens. Direct bacterial agglutination uses whole pathogens as a source of an antigen. The binding of antibodies to surface antigen on the bacteria results in visible clump. Examples of direct agglutination tests are Widal tests, ABO typing, and viral hemagglutination. To simplify this class, here you have your bacteria. On the bacteria would have the different receptors known as your epitopes, and the antibodies will attach to these epitopes class or receptors, and it would form lattice a visible agglutination. So simple as that. Particulate antigen plus antibody produces a visible agglutination. That's your direct agglutination. From the word direct class, it's just between an antigen and an antibody to form an agglutination. Now let's go another type, viral heme agglutination. For viral heme agglutination class, the principle here is that this is a type of viral heme agglutination test that uses the ability of some viruses to bind to RBC, resulting in agglutination. Sa viral heme agglutination class, in viral heme agglutination, for you to understand here, viruses replace your antibodies. So instead of having antibodies, you would use viruses here. Now, viruses here, class, would attach to your antigen, specifically red blood cell. And if they would form lattice, if they would form sensitization, then lattice, it would form an agglutination. So take note of that. Just the difference class between direct heme agglutination is that in viral heme agglutination you use viruses instead of antibodies to produce agglutination. Example of a virus that can cause heme agglutination class, please take note, is the influenza virus. Then let's go to the third one. This one class, yung indirect or the passive agglutination. Now, in an indirect or passive agglutination, you will be using inert particles or cells with no markers, are coated with a known soluble antigen and mixed with a serum. So you would use particles class. An example of an inert particle is yung latex. So here you would have your latex and it would be coated with an antigen. So later, para magets nyo siya, ito siya. Yeah. So this is your antigen. This is your particle or inert particle. This could be latex class. Example lang. So here you have your latex. Here you have your soluble antigen. They would attach now to your latex. The reason why you need to attach them class or to absorb them is because these are not particles. These are soluble antigens. An example of a soluble antigen is hormones. There are certain hormones. So take note of that. The soluble antigen is passively absorbed or chemically coupled to red blood cell or inert particles such as latex, gelatin, silicate, charcoal, or bentonite. If clumping occurs, the patient's blood contains antibodies specific to the antigen. This is typically precipitation converted to agglutination by increasing the size of antigen particles. So if we want to compare this with direct agglutination, if in direct agglutination class, you would only use your antigen plus antibody to produce agglutination. But in passive, as I mentioned earlier, if it's passive, you would use antigen plus your inert. Pag sinabi niyong inert, if you say inert, it's inactive. Inert particle, so antigen would bind to an inert particle plus an antibody to produce a agglutination. So take note of that. So they are passively adsorbed to the inert particle. Examples of indirect agglutination tests would include your latex agglutination test for ASO or your antistreptolysin O, infectious mononucleosis monospot latex agglutination test, and latex agglutination test for rheumatoid factor. So this is an example class of the principle of your ASO test or your antistreptolysin. Latex test for ASO. So here we have your latex coated with the antigen streptolysine O. Diba si streptolysine O class is an enzyme. So this is a substance or that would require a particle for it to be enlarged or for it to be visible. So we have your streptolysine O would attach to latex particles. You add your patient serum that contains anti-streptolysine O. If the patient is positive for streptolysine O, it would now form an agglutination. So take note of that. But if the patient is negative, there is no agglutination or clump. Now let's go to the fourth one, reverse passive agglutination. So from the word reverse, this time it's the opposite class. So this time class, you would now be using an antibody plus your inert particle. In passive agglutination earlier, in passive agglutination, you would have again antigen plus your inert particle plus antibody. But in the reverse passive, you would have your antibody attached to an inert particle, then you add your antigen. So when the inert or carrier particle is bound not to an antigen but to a known antibody, this is referred to as a passive reverse passive agglutination. So instead of having an antigen attached or bound to an inert particle sa reverse passive class, you have an antibody bound to an inert particle. Now the antibody must be oriented in such a way that the active site is facing forward. This is used in the detection of microbial antigens such as group A and B strep, Staph aureus, Neisseria meningitidis, Haemophilus influenza, Cryptococcus neoformans, Mycoplasma pneumonia, and Candida albicans. So this is an illustration class. So here we have your inert particle or your carrier particle plus antibodies. You will now have a antibody coated particle. The antibody coated particles now class will attach to multiple antigens with multiple determinant site, forming visible agglutination. So do take note of that. Latex agglutination test for CRP class is an example of a test that follows this principle. Now, another type of agglutination is known as your co-agglutination. In co-agglutination class, you're going to use protein A. This is produced by Staphylococcus. Sorry. Staphylococcus aureus, Co1I strain that has high affinity for IgG antibodies of certain species. Such bacterial cells can be coated with specific antiviral antibodies which bind via their Fc portion to the protein A molecules, leaving the PAB portion free. Okay. Sa co-agglutination class, you would be using a type of particle. The particle that you're going to use here is protein A produced by Staph aureus. So ito si Staph aureus nyo class. On the surface of Staph aureus, you will find protein A. Now, this protein A class has an affinity. May affinity daw siya to the Fc portion of the antibody. When you say affinity, attracted siya sa Fc portion ng antibody. That is why when your antibody attaches to the protein A, it will leave the Fab portion free. Tingnan nyo tong picture na to. Take a look at this picture, class. This is the protein A, and what is attached to the protein A class is the Fc portion of the antibody. And if you take a look, the Fab portion or the Fab sites are free. Now, once you add your antigen, Once you add your antigen, the antigen with its receptors on its surface will now be able to attach to the Fab sites, producing agglutination class. So Staph aureus Co-1 strain are more stable, economical, and resistant to ionic changes than latex beads. So they would use this as a substitute class. Instead of latex beads, gagamit sila ng S. aureus Co-1 strain. The coagglutination reaction is highly specific but may not be as sensitive for detecting small quantities of antigen as in latex agglutination. Then let's go to the Coombs test class, or the antiglobulin mediated agglutination. So this is the one that I mentioned wherein they created an antibody that targets the FC portion of an IgG. So the anti-human globulin contains an IgG with specificity for the constant region of other IgG antibodies. When this binding occurs, a bridge is created between IgG-bound red cell, causing them to form visible agglutination. There are two types of AHG, the direct and the indirect antiglobulin tests. Both tests involve IgG and anti-human immunoglobulin mediated hemagglutination. So let's go first to the DAT, or the direct antiglobulin test. So the direct antiglobulin test measures whether antibody is present. Please take note of this. Is present on an individual's RBC. So this is an example class. Here, to simplify, I want you to remember this. If it's DAT, or direct antiglobulin sensitization, or antiglobulin test, you are detecting for in vivo sensitization. When you say in vivo, inside the body. So this is the procedure class. Here you would get your RBC sample. Your RBC sample. Now your RBC sample, let's presume, is that it's already coated. It's already coated with antibodies. Now you get your reagent, your anti-human human globulin reagent, or your AHG. Now, your anti-human globulin reagent, or your AHG, is a type of IgG that would target the Fc region of another IgG. So once you add your AHG, now it would attach, ito yung AHG nyo class, this yellow one. It would now target the Fc region of those antibodies already attached to the red blood cell. And this will cause it to agglutinate. So let me repeat, if it's direct antiglobulin test, this is a test for in vivo sensitization, whether an antibody is already present on an individual red blood cell. So here you have your red blood cell that is already coated with antibodies. You now add your anti-human globulin reagent. And remember, your anti-human globulin, or your anti-human antibody, targets the Fc region of IgG. That's why if you take a look at the illustration on this third part, you will see that the antibody, the AHG, would target the Fc region of the antibody coated in the red blood cell. So that's your DAT. Now let's go to another one, yung indirect. Let's go to the indirect antiglobulin test. So when we talk about indirect antiglobulin test, you're looking for the presence of patient antibody to red blood cell. So if it's IAT, or IAT, this is a test for in vitro sensitization. When you say in vitro, this is in the laboratory or outside the body. So here you would be using this time class a serum sample. So your sample is a serum. Your reagent this time is 2. Reagent 1 is your RBC. After you add them, you let it stand, you let it stand, then you now add your anti-human globulin. If there is sensitization class, di ba, you let it stand. If there is sensitization between the serum sample and your reagent 1, which is an RBC, it would now cause the RBC to become coated with antibodies. Now you add your AHG. And if you add your AHG class, and if there is agglutination, it just means class that your serum, there is the presence of patient antibody to red blood cell. And most of the time, this indirect anti-human globulin test is done in your cross matching. So if there is agglutination in this phase, the AHG phase in cross matching, the patient is not compatible. Why? Again, you are testing for patient antibody to red blood cell. Imagine if the serum, this is the serum of your patient. The patient class is your recipient. Sa Tagalog, in Tagalog, siya yung tatanggap ng dugo. If there's an antibody and that would target the RBC, in this case, the reagent RBC is the donor RBC. So the donor RBC, if this is transfused to the person, the antibodies of the patient will attack. This will attack the the RBCs because there is affinity towards one another, and that could lead to hemolytic transfusion reaction or HTR. That's why it's very important that you would perform AHG tests. So I hope it was clear the difference between that and IAT. That is done for in vivo sensitization, meaning the red blood cell of our body is already coated with antibodies. But if it's in vitro, you're testing your serum if it's compatible with a certain type of RBC. Let's go to agglutination inhibition. Based on the competition between particulate and soluble antigens for limited antibody combining site. So this time class, there is a competition between a particle and a soluble antigen for limited antibody combining site. Agglutination inhibition or hemagglutination inhibition is the inhibition of these reactions, preventing their binding to and agglutination of the particle. Absence of agglutination class, please take note, is a positive reaction. So, ang positive result dito is no agglutination. Common tests that follow this principle class are latex particulate agglutination inhibition or the classic test for HCG. Di ba ang HCG nyo is, this is the pregnancy test. You would use this for pregnancy. And then there's the viral hemagglutination inhibition. So for you to understand this class, ito siya. So this is the latex test for HCG. Now, in your urine, you would be using here a sample. Your sample here would be urine, and you would use using reagent here. Your reagent here is HCG antiserum. So you would use your urine. Your urine, if you're pregnant, example, you're pregnant, your urine would contain human chorionic gonadotropin. Human chorionic gonadotropin plus you add the reagent HCG antiserum would be neutralized. There would be neutralization of the antibody. Sir, why is there a neutralization? Remember, your HCG antiserum would bind would bind to the HCG because they are attracted to one another. HCG antiserum is a reagent that would attack or bind HCG, leading to the neutralization of your antibody. After that class, you add another reagent. This time, you add HCG-coated latex particles. But this time, since Since you've already neutralized since you've already neutralized the antibody by having the HCG antiserum bind with the HCG, there would be no free Fab site. Walang free Fab site. There's no free Fab site. There would be no site for this HCG coated latex particles to attach. Thus, there would be no visible agglutination. What if naman if the patient is non-pregnant? So again, if it's non-pregnant, you would use your urine. But this time, if you're not pregnant, there's no HCG. If there's no HCG class, HCG antiserum will not bind to HCG. Meaning this time there will be free Fab sites of the HCG antibodies, anti-HCG antibodies. The antibody is not neutralized. There is free Fab site, and when you add the HCG coated latex particles, this will now attach to the HCG antibodies, forming visible agglutination, which is again, in this case, a negative result. So I hope that was clear. Let's go to a type of inhibition class, yung viral heme agglutination inhibition. So this time, certain red blood cells, please take note of this, have naturally occurring viral receptors. When a virus is present, spontaneous agglutination would occur because the virus particles would link the RBCs together. Presence of patient antibody inhibits the agglutination reaction. So for you to understand this class, in this type of inhibition assay, viral heme agglutination inhibition, you would be using here viruses and your serum. Now, when you mix them together, you would have your virus and antibody. You would incubate them together. Now, the virus would bind with the antibody. And when that happens, when the antibody binds to the virus, this will cause an inactivated antibody. Why again inactivated? Because the fab sites are not free. That is why when you add your RBC, the antibodies would block the RBCs from binding the virus. So take note of that. But if it's this is a positive result class because there is no agglutination. Because again, the antibodies prevented the RBC from binding the virus. But if it's a negative result naman, in this case, you have your antibodies, but this time there is no, you have your viruses rather, sorry. You have your virus, but this time there is no antibody. So in this case, when you add your RBC, the RBC can now attach to the virus, leading to a negative result of agglutination. So that basically ends the type of agglutinations. I hope you were able to learn something. Thank you.